term 1. This is the last lesson of just doing general calculations. You don't need to know titrations if you're not going to be really continuing on and you're not going to be doing the 919 standard, 10 standard. But if you're going to be doing, say, the level 3 chemical reactivity, then it's good to know how to do these titration calculations. And then next term, we're going to do a deep dive into all the details you need for the 91910 level 2 calculations, so that you're prepared for the chemistry day that normally is held towards the end of term 2. Okay, so where do I find this booklet that I'm going to be working with? Hopefully most of you do know this already, but if you go to the level 2 course and you go to content and you look for 2011 and you look at the landing page of this module, this is where you find the booklet. You can choose between a PDF or a docx Microsoft version, and then of course the answer guide to check your answers. Do not work through the modules. You're just wasting your time. You just work through the booklets and that'll teach you everything. Within the booklets, there are also links to videos. So let's have a look now at this booklet, and we're going to be looking at titrations. And this is sort of a sketch of what the titration looks like. In a proper lab, it can come in various forms of a titration, but this basic equipment I have seen when I visited a vineyard, and they use this to calculate, to work out acidity of the wine and the sulfur content and so on. So this equipment may look old-fashioned, but you may still use it if you become, say, a winemaker or other things. So basically we have what we call a burette, which is this object over here, a long thing, and you'll notice it's got measurements along the way, so you can take varying amounts of substance. And then we also have what we call a pipette, which I haven't shown here. And the one we tend to use delivers a fixed amount. There are different shapes, but most schools have the one where it's sort of a long, narrow shape with a bulb in the middle, and then it comes down to a point. So it sort of looks something like that. And that delivers a fixed amount. So what we add to the pipette, or the solution in the pipette gets added to this conical flask down here. We use the conical flask because when you come and do this titration in a practical sense, you have to swirl that flask quite a bit. And if you just had an open beaker, then a lot of your stuff can splash out. So it's sloped inwards just to try and keep the solution in the container. So we call this a Erlenmeyer or a conical flask. Conical describes it a much more. So we first put solution in here, so call this solution A, and then we add solution B. So can you see we have two different solutions, and they react. We keep on adding from the burette until our solution A that we put in is neutralized or has finished reacting. So the one you're going to be working with is an acid base, but you can do any sort of chemical reaction this way. So in the, say, the 91910 assessment task, we'd have base in the burette and acid in the using with a pipette into the conical flask, and you would then add sufficient base just to make sure that all the acid has reacted. And the way we know that is we add an indicator, which is pH sensitive. It has a different color depending on the pH. So at the correct pH, it changes color, so you know it is now finished. So that is overall what a titration is. It's looking at two solutions, having a fixed amount of one, adding a variable amount of the other, where you can do drop by drop by drop if needed to be very accurate. And then you stop adding when there's been a color change or some sort of indication that you have now completed the reaction. You can even use as an indicator temperature changes. There's a lot of different ways you can know when the reaction is just completed. So let's look at the calculations. And I'm going to hop from here. So there are lots of videos on how to, what they are. We're not going to look at errors and technique at the moment. So we're all going to flip through there. That's all what we're going to be doing next term. That's all next term. And we're going to go all the way down to this page. It's supposed to be page 4. Yeah. Okay. A little bit further down. Titration. Okay. So what we have here is an example, a worked example. And can you see this term that we use, aliquot? If you see the word aliquot, you know that you are talking about what you have added with the pipette. Sorry for this weird language. I mean, I don't know why they came up with aliquots. So if you pipette fixed amounts, you talk about aliquots. If you adding from the burette, then we call it a titer. So that's a good way to work out, does it come from the pipette or does it come from the burette? So if you hear about titers, you know it's been added from the burette. That's a long, thin, variable amount. And if you talk about aliquots, which goes into the conical flask, it's the pipette. So here we have, and you'll notice there are always 2 solutions, and you know the concentration of one of them, and you're trying to find out the concentration of the other. That's the whole point of a titration. So if you have a look here, I have one solution called sodium hydroxide, and I don't know anything about sodium hydroxide. All these other values are not relating to sodium hydroxide. We're going to ignore this at the moment because, as I say, we're just doing a straightforward titration. We do have, though, another solution, which is an acid. So I have that value related to that substance. And I also have got volumes given. I have given the sulfuric acid volumes, which is down here. So let me just actually rub off this yellow and turn it into blue. So basically we can say all I know about sodium hydroxide is this volume. I know nothing else. For sulfuric acid, I know 2 things. I know this value and I know that value. Now, remember what I said in previous lessons, it's really important that you learn the units of different quantities, because then you know what it's talking about. So what is this 0.0500 mole per liter? So mole per liter gives you a clue. It's a unit. What quantity do we measure in mole per liter? Is it N? Is it M? Is it big M? Is it C? Or is it V? It's one of those 5. Does anybody? It's mole per liter. So N is measured actually in mole, just straight mole.
Oh, shit.
Mass is measured in grams. We're getting there. Molar mass is measured in grams per mole. Come on, we've got 2 left. Which one do you think it'll be? So let me look at the chat in case I didn't see everything. So you got 2 left. Is it C or is it V? What do you think? Have a go. C, yes, it's C. So this is mole per liter. And I think last week I did say there was that little poem you could learn to try and remember. So I think it went something along the lines of volume, amount, and mass have units without a dash. And by that, I mean, they don't have this to the negative. And it's liters, mole, and gram. Those are those different ones. So liter is the one for volume. But molar, mass, and concentration have ideas above their station, double barreled, not repeated, and that's grams per mole and mole per liter. So it's got two things to it. It's gram per mole. So all the others are like mole, gram, liter. Molar mass and concentration have got two parts to it, grams per mole and mole per liter. So if you see mole per liter, then you know that that value is the concentration related to sulfuric acid, because it's linked to sulfuric acid. And if you see milliliter, then you know that this is a volume, okay? But I've got to do something because volume is measured in liters, not milliliters. So what do I need to do to change milliliters to liters? There's always this extra step I have to do. Well, it's actually divide by 1,000. You're right with 1,000, because if you think about it, 1 milliliter is less than a teaspoon. So if I multiplied it by 1,000, I don't have that many liters. It's a tiny bit of a liter. So I always say, try and imagine what it looks like in your mind to work out whether you multiply or divide. So if I only had like 5 mils, I don't have a great big whopping amount. I just have a tiny little bit. So it's got to be a lot less than a liter. Okay, so you'll also notice that what we do here is we're going to ignore the rough because we're not doing technique at the moment. But can you see we repeat the experiment a few times? We don't just do this once. And if you've done any level 1 practical investigations, has anybody done any level 1 practical investigations where you look at variables and having to repeat an experiment to make sure that your experiment is reliable? Have any of you done any of those? Okay, it doesn't matter if you don't know, but pretty much what you have to do is you have to repeat it a few times to make sure that your results are reliable. And then what you do is you choose your best 3 results or more if you've done it a few times. And by your best 3, we say make sure you have 3 results within 0.2 milliliters. If they all weigh out, then your titration technique isn't very good. So you keep on practicing until you get 3 results within 0.2. And you can see these are all within 0.2, but that one is more than 0.2. It's within 0.3 of this one, and it's 0.35 of that one, and it's within 0.25 of this one. It's within 0.2 of this, but you know, they are just too far apart. So we're going to ignore the 20.75 because that was a bad result of my experiment. So let's now, in the last 15 minutes, do examples of this calculations. Oops, let me just go down. So as per normal, whenever you do a calculation, always try and work out what substance you're working with and what the quantity is. You know, is it a concentration, a volume, or what is it? So the first step you would always do is work with what you've got. And remember from, you know, I've scrolled down, but what we had was we had the concentration of sulfuric acid. Okay, we had a whole lot of volumes of sulfuric acid in milliliters, and we had a volume of sodium hydroxide of 25 milliliters. So we're going to focus on the sulfuric acid because we know more about it. So the first thing we're going to do is we're going to try and work out our average volume for the sulfuric acid. So we take all our results that are within 0.2. So we say 20.45, 20.40, 20.55 plus 20.50. So all the ones from the previous page. And because I took 4 results, I divide by 4. Okay, and I get the average. So this is a straightforward averaging thing. If I took 3 results, which would have been fine too, never take less than 3 results. I mean, you could have done 20.45 plus 20.4 plus 20.5, and that would have also been acceptable. But in that case, you would divide by 3. If you only take 3 results, you would divide by 3. Okay, so you've got an average. Now, the next step is you've got milliliters. So you have to convert to liters because remember, your volume is always measured in liters. So I divide by 1,000, or what I just do, I just multiply by 10 to the minus 3. And that's just because I can then just go in my calculator, exponential 3 minus, and it's just very easy to do. You've all got different calculators, so you've got to find what works for you. Okay, right. So we now have the sulfuric acid. It's this over here. I also have a concentration for sulfuric acid. So if I know V and C, what equation can I use, or what formula can I use to work out something else? I'm being particularly vague there because sometimes people go, I don't know what to do next. So I just say, think of a formula that's given to you where you know 2 out of the 3 things and then calculate the third. So the 2 formula you are given is C is equal to N over V, and the other one is N is equal to small m over big M. Which one of these 2 would you use? C is equal to N over V, or N is equal to small m over big M? Bearing in mind that we have got for sulfuric acid, remember it's got to be for the same substance. I can't mix up sodium hydroxide in here. It's got to be sulfuric acid and sulfuric acid. So I've got C and I've got V. So if I've got C and I've got V, can you see I can calculate N? Ah, okay. Well done for having a go, okay? And good, Campbell. Right. So, and I always say, and this goes for any calculation, even like in the exam, if you don't know what to do, calculate the amount in mole. Just do that and you'll probably get an achieved grade for that question. So just because everything works out by amounts. You know, if you think of dancing and you've got dance partners, if it's a ratio of one person to another person dancing, you know, if you want to know how many partners are going to be on the dance floor, you've got to take it and divide it by 2 sort of style. So it's always to do with amounts. How many of this is going to react with how many of that? So here is where we've done this now. We've said C is equal to N over V. So if you want to get N by itself, because it's dividing by V on this side, to get rid of it, I have to multiply both sides by V. So can you see that I've got now N is equal to C times V? If you're not sure of your algebra of moving this around, you can get away with these triangles where you've got C is equal to N over V. The thing is, you've got to make sure you remember the triangle correctly. Another way, which I think is a better method, is to try and work out, will your units cancel? So if you look at my units over here, mole per liter multiplied by a liter, So I'm saying mole over liter, because that's what mole per liter means, times liter. Hopefully you can see liter cancels out with liter, giving me an answer of mole. And is mole the correct unit for amount? Is that the correct combination? Do I measure amount in mole? You got a 50% chance of being right. It's either yes, that's the correct unit, or no, it's the wrong unit. Yeah, it's the correct unit. Okay, so it's just simply a straightforward calculation in your calculator. You take the concentration that was given, and then you multiply by the volume, the average volumes that you've now converted to liters. And can you see, if you hadn't converted to liters, you would have landed up with milliliters, and milliliters do not cancel out with liters. And that's why you have to do that conversion to liters. Now, we're going to go back to this mole ratio. The mole ratio is whenever you swap from one substance to the other. So I've worked with sulfuric acid all the way through, but I need to find out the concentration of sodium hydroxide. And I can't put more than one type of substance in a formula. It's in my N is equal to C times V. It's got to all relate to the same substance. You know, sulfuric acid, sulfuric acid, sulfuric acid. I can't have something with sulfuric acid and something with sodium hydroxide in a formula. So the only way to go from one substance to the other is to use this mole ratio. And we get the mole ratio from the equation or from a formula, depending on what's being asked. So in this case, you were given the balanced equation further up, but I'll just rewrite it. Here it was sodium hydroxide plus sulfuric acid gave you sodium sulfate plus, so it's supposed to be a 4 in case you can't see it, plus water. And I need 2 of those to balance. Hopefully you can see that. You will be given a balanced equation. So what you need to do is you need to look at the numbers in front of the things, of the substances you're comparing. So I am looking at sodium hydroxide and sulfuric acid. So I have a 2 in front of the sodium hydroxide. And what is my number in front of sulfuric acid? For those that have come to previous lessons, I always say chemists are lazy and they try and do as little as possible. So if there's no number, it always means, it's a 1. Okay, so we don't write a 1, we just assume. So if there's no number, it's a 1. Other examples where you use that, I don't say H2S1O4, I just say H2SO4. So we never bother with ones. We just assume if there's no number, it means a 1. So my mole ratio is I've got 2 sodium. I need double the amount of sodium hydroxide to sulfuric acid. So when I do my mole ratio, there are different ways of approaching it. Some students just like plugging it into a formula. And so they don't necessarily want to understand what's going on. They just want to put it into a formula and get the right answer at the end. Others want to know what's going on. So here, just to do the straightforward formula, if you use a mole ratio and you always put the unknown substance number at the top with the known one at the bottom, you'll come up always with the right mole ratio number. So what do I mean by this? Let's tidy this up. Remember, we were working with sulfuric acid all the way through up here. This is all sulfuric acid. So this is what I mean by our known. We've got the C, we've got the V, we've got the N. So this is our known. So we look at the number in front here, and that is the number we put at the bottom. It's always in the denominator. And then for our unknown, in this case, it's sodium hydroxide. We don't know much about sodium hydroxide. All we know is that we use 25 milliliters. That's all we know. So that's what we say is our unknown, because we don't know much about sodium hydroxide. And we look at the number in front of the sodium hydroxide, put that on the top, and we go top number divided by bottom number is going to be my final ratio. Do you all follow? So that's a straightforward plug and chug. Put the one you know least about on top and take whatever number is in front of the balanced equation and put that one there. And then the number, the substance you know most about, you know the C, you know the N, you know the V, you put that number from the equation at the bottom. And then so you divide the unknown by the known and you get your mole ratio. Another way to view it is just simply to say, from my equation, I need double the amount of sodium hydroxide to sulfuric acid. So I must have a final double. So if I had 1.0238, blah, 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 I must have of sulfuric acid, I must have double that for sodium hydroxide. So I must have 0.046, whatever. Okay. So carrying on over here. Okay, my mole ratio, remember that number from before was for 2. So whatever amount I had for sulfuric acid, I take that number and multiply it by 2. So there's my answer for that. And now I say, okay, I now know for sodium hydroxide, I know N because it's that. So tick for this. I know V because in my original equation, my aliquot was 25 mils. So I know my volume. I've got to still, of course, convert my milliliters to liters. So if I know N and I know V, I can work out C, which was the whole point to the question. So remember, C is equal to N over V. So if I know N and I know V, then I can work out C. So the first thing you do is, of course, your volume for sodium hydroxide. It was 25 milliliters. So can you see, I just simply multiply by 10 to the minus 3. Do you notice that these will cancel out? So actually, if you didn't do the times 10 to the minus 3, you get the final correct answer, but you're not going to achieve the standard. You do need to show that you know you have to convert milliliters to liters. So don't take the shortcut. Don't not convert, because it's going to backfire. So now you just simply take your value that you calculated there, divide by the aliquot volume, and you originally added 25 milliliters of solution, and you get your answer. And remember, whenever you do an answer, there are 3 things to do. Have you got the correct unit? Have you got the correct number of significant figures? And then the final question you ask yourself is my answer sensible? So let's look at the first one. Have I got the correct unit? Hopefully with practice, you'll remember that concentration is measured in moles per liter. So yep, that's correct. Have I got the correct number of significant figures? Yep, I've got 3 significant figures. And remember what I said, if in doubt, use 3 significant figures. For those that want to know a bit more, is if you go back to the original question, you'll see all the measurements were given to either 3 or 4 significant figures. So if I go over here, can you see these are 4 significant figures? All my measurements here were 4 significant figures. That was 3 significant figures. That was 3 significant figures. So you always take the least accurate number of significant figures, and 3 is less than 4. So your final answer must be 3 significant figures. But as I say, if you aren't sure, just give your answer to 3 significant figures. And that makes it so much easier. And so then that is, whoops, your final answer. So remember, the final question is, oh, don't worry about this because we haven't done the dilution. We just get to this point. So your final question is this answer sensible? So you go, okay, I started off with 0.05 moles per liter of sulfuric acid. And I used round about 20, what was it? Well, close enough to 25. It was 26 or so. What was it? Can't remember. Somebody else remembers. What was it? It was, what was our average? 20. Yep. Let's go down again. So it was round about 20 or so milliliters of sulfuric acid. So bearing in mind, I need twice the amount of sodium hydroxide. If I had equal volume of sodium hydroxide, I would expect my concentration to be 0.1. But I didn't have quite equal amounts. I had 25 milliliters instead of around about 20. So it's not going to be quite 0.1 moles per liter. It'll be a bit less than that. So that answer looks very sensible. So hopefully we've done now our half an hour. Hopefully that gives you an idea of working through. It might look difficult, but if you just take it step by step by step. So I'll just start this one just to show. The first thing you always do is try and isolate what is in the ones, what are the figures all related to the one substance and what are all the figures related to the other substance. So if I just tidy this up a bit by removing all that, okay. So for instance, over here, you can highlight, you can underline. Can you see what you've got here? You've got sodium hydroxide. Whoops, come on. You've got sodium hydroxide. What are all the values related to sodium hydroxide? That is related and that is related. What is my other substance? My other substance is sulfuric acid. And the only thing I've got for sulfuric acid is a volume over here. So the next step, once you've isolated that, is to go, okay, what do these figures mean? So this is where you do need to know the units. This is the concentration of sodium hydroxide. This is the volume of sodium hydroxide. And because I know C and I know V, I can work out N because, C is equal to N over V. So therefore, N is equal to C times V. And for my other one, this is now my unknown because I know least about is my sulfuric acid. The only thing I know about it is my volume of sulfuric acid. Now, I hope you see that I'm always indicating the substance I am dealing with. Do not just do a whole lot of numbers, okay? Or you just say N is equal to C times V and just plug and chug numbers on there. Always say what N you're calculating. Is it N for sulfuric acid or N for sodium hydroxide? And good question, Star. Do we have to memorize the conversion formula? By conversion formula, these are given. So C is equal to N over V is given, and N is equal to small m over big M are given. They're given in assessment tasks always and always in exams. You may need to just, you've got to do this, what we call changing the subject of the formula. So you've got to do that. So I hope I've answered your question. Okay, so we'll leave it there. And that's it then for this term. And if you've gone through all of these, then you'll be fine for carrying on next year for level 3. Next term, though, I will focus on the 91910 standard, because you've got to know about errors and so on, because you've got to write a report, because it's an investigation. So, you know, you've got to look at what you've got to keep constant and variables and all that sort of stuff. Any other questions? Right. Have a great holiday. If you're a little bit behind, it might be a good time just to catch up in the holidays with a bit of work. But please make sure you have 1 week of a total break. So if you are behind, work hard next week, and then the next week you can just have a break. So is the practical chemical thing a test? Yeah, every teacher runs it slightly differently. There are 2 parts to the 91910 standard. One is a practical assessment. So yes, it is sort of time limited. So if you come down to me in Wellington, basically what I show you how to pipette, I show you how you rate, and then you just keep on practicing until you get 3 good results. And then you do the key calculations then with me, but you can finish them off at home, but they have to be supervised. Okay, so we take in your stuff and we give it to you when you're ready. There is also another big branch of calculations that you do beforehand to prepare, and that you do at home. Again, it has to be supervised. So you can't just do it on your own. Hopefully that helps. So there's no real time limit, but if, hey, you won't get 8 hours, I can tell you that, because we're going to all be exhausted and we want to kick you out the lab. But we're not as time limited as you would be in, say, a school, where when the school bell goes, you've got to go off to your English or whatever. Right. So I'll just switch off the recording, and if there's any other questions,